So in your notes, we're on page 23, and we're going to take a look at section 8.6 about properties of logarithms. If you have not done anything with logarithms in the past 3 weeks, I'd like to recommend that you pause the video and take a few moments and just refresh your memory from sections 8.4 and 8.5 about how logarithms work. Otherwise, today is going to seem more difficult than it would otherwise. So take a moment and just refresh your memory about logarithms. We have 3 properties of logarithms: how to add logarithms, subtract logarithms, multiply logarithms by a number. Our first property involves how to add logarithms together. I have log base 2 of 4 plus log base 2 of 8 equals, well, it should seem reasonable that the answer should be another log base 2 problem. It would be really nice if this equaled log base 2 of 12, 4 plus 8 is 12, but unfortunately logarithms don't work that way. So before I tell you the property, let's see if we can kind of rationalize what's going on here. Log base 2 of 4 is like asking the question, 2 raised to what power gives us 4? Hopefully you realize that's 2. Log base 2 of 8 is asking the question, 2 raised to what power gives us 8? Hopefully you realize that's 3. 2 plus 3 is 5. I need a log base 2 problem whose answer is 5. Think about that for a moment. A log base 2 problem whose answer is 5. This is like saying log base 2 of something that I'm not sure of is going to equal 5. And if I take this idea and convert this thing in logarithmic form into exponential form, I could say 2 to the 5th power is that thing inside. I think I'm going to get 32. What log base 2 problem gives me 5 as an answer? Log base 2 of 32. What we need to get out of this, though, is how are we taking 4 and 8 and getting 32 out of them? Well, we're multiplying them together. When we add 2 logarithms, we multiply the stuff inside. Our first property says log base b of some number m plus log base b, the same base, of some number n, is going to equal log base b of m times n. When we add 2 logarithms together, as long as they have the same base, all we're going to do is multiply the stuff inside them. So let's take a look at these 2 examples down here. Letter A, log base 3 of 7 plus log base 3 of x. Well, this is going to equal log base 3 of, when I add 2 logarithms, I multiply the stuff inside, so I'm going to multiply 7 times x and just get 7x. Log base 3 of 7x. Might make a little more sense if I stick it in parentheses, so I'll say log base 3 of, in parentheses, 7x. Over here, in example B, I'm adding 3 logarithms together. Well, it's going to work in the same way. I'm going to get log base 5 of, and we're just going to multiply x cubed times x to the 7th times 2. Any constant should usually go out front, so I'm going to write this as log base 5 of 2, x to the 3rd, y to the 7th. When you add logarithms, you multiply the stuff inside. We'll come back to this later when we start mixing it with some other properties. But now, we need to look at property 2. That talks about what happens if we're going to subtract logarithms. Maybe take a guess. If adding logarithms means multiply the stuff inside, guess what you think is going to happen when we subtract logarithms. I know my answer is going to be log base 3 of something, and it's not as easy as just doing 81 minus 3 and getting 78. So to kind of figure this out, I'm going to go through the logic the same way I did in that first problem. Log base 3 of 81 is asking 3 raised to what power gives me 81? I think that's 4. Log base 3 of 3, 3 raised to what power gives me 3? 1. 4 minus 1 is 3. So I need a log base 3 problem whose answer is 3. Think about that for a moment. And maybe you came up with 27, because log base 3 of 27 is 3. 3 raised to what power gives me 27? 3. How are we taking 81 and 3 and getting 27 out of that? We're dividing those numbers. Our second property says if I want to do log base b of m minus log base b of n, when we subtract two logarithms, we divide the stuff inside. So I'm going to get log base b of m over n. I'm going to get a division problem like that. So let's take a look at a couple of examples here. I want to condense these logarithms into a single logarithm, so basically take the two or more logarithms and turn them into one logarithm. Log base 6 of 20 minus log base 6 of 5, I'm going to get log base 6 of, well, I'm just going to divide those things. Log base 6 of 20 divided by 5. We shouldn't leave it like that, though. We should actually go and do the division problem, and we'll get log base 6 of 4. Log base 6 of 20 minus log base 6 of 5 equals log base 6 of 4. Quickly try letter B. Log base 5 of 8 minus log base 5 of y squared. I'm going to divide the stuff inside, and I can't do much more to it. I'm going to say log base 5 of 8 over y squared. When we add logarithms, we multiply the stuff inside. And when we divide logarithms, when we subtract logarithms, we divide the stuff inside. Let's look at a few more examples of this. Letter C on the next page. Log x plus log y minus log z. First of all, there wasn't a base given. Hold on, let me try to focus this a little bit better. Maybe that's a little bit better, I'm not sure. There wasn't a base given, but hopefully you remember that that's what we call our common logarithm, and it's like the base is 10. Doesn't really affect any of our work, but if you want to write in a 10, you're welcome to write in a 10. Now, I see an addition problem, and then I see a subtraction problem. Well, let me use my normal order of operations and do my addition and subtraction in order from left to right. Log x plus log y, you're adding those two logarithms, you're going to go and multiply the stuff inside. I'm going to get log x times y. Then, after that, I have that subtraction problem, so I'm going to say that log xy minus log z is what the original problem is the same as. Okay, well now we're subtracting these two logarithms, which means we should divide the stuff inside, and I'm going to get log base 10. No, you don't have to write it. If you don't write a base, you're implying that the base is 10. Log base 10 of xy over z is how that one's going to work. When we add logarithms, we multiply the stuff inside, and when we subtract logarithms, we divide the stuff inside. That next example is going to be a pain. I need to multiply 8 times x cubed, and then divide that by y to the 5th, and then divide that by z to the 6th, and then multiply that by q to the 8th, and then divide by n to the 28th. There's an easier way to deal with this problem. And actually any of these problems that involve several addition or subtraction problems. If you look back at letter C, the logs that had like a positive sign before them, so our log x plus log y, the stuff inside those logs ended up on the top of a fraction inside our log. The logarithms that had a negative sign before them, the stuff inside that log ended up on the bottom of our log. To sort of summarize this, I can say that for any log, with a plus before it, put the stuff inside that log on the top. Oops. Let me zoom out so you can see the whole line all at once. And in the same breath, for any log with a minus sign before it, put the stuff from inside that log on the bottom of a fraction. These two ideas are going to let me deal with problems like letter D very, very quickly and not have to do just one step at a time. For any log with a plus before it, put the stuff inside that log on the top. For any log with a minus before it, put the stuff inside that log on the bottom. This is going to end up equaling log base 3 of, well, I'm really just going to go piece by piece and decide, will the thing inside that logarithm go on the top of a fraction or on the bottom of a fraction? Log base 3 of 8. Well, that log was positive, so I'm going to stick the 8 on the top of my fraction. Log base 3 of x cubed. That log was positive. I'm going to stick the x cubed on the top of my fraction. Minus log base 3 of y to the 5th. That log was negative. I'm going to stick my y to the 5th on the bottom. This next log, log base 3 of z to the 6th, is also negative. I'm going to stick the stuff inside that log on the bottom, so I'm going to say z to the 6th on the bottom over there. Plus log base 3 of q to the 8th, that log was positive. I'm going to stick a q to the 8th on the top. And this log base 3 of m to the 28th, I'm going to stick that m to the 28th on the bottom because that was a log that I was subtracting. Any log that had a positive sign before it, the stuff inside that logarithm goes on the top of a fraction, like 1, 2, 3. And any log that had a minus before it, the stuff inside that log will go on the bottom of a fraction, y to the 5th, z to the 6th, m to the 28th. That's our second property of logarithms. Third property of logarithms. 2 times log base 3 of 9. This property involves what happens when we multiply a logarithm by some number. Again, I'm going to start by kind of working with some numbers to get a sense of what this property is, and then I'll write out the property in its general form. I know log base 3 of 9 is like asking 3 to what power gives us 9, and we're going to get 2. We're going to go do the problem 2 times 2, and we're going to get 4. I want a log base 3 problem whose answer is 4. Think about that for a moment. A log base 3 problem whose answer is 4. Should be an 81. Log base 3 of 81 is like asking 3 to what power gives you 81? It's going to be 4. How are we taking this 2 and this 9 and getting 81 out of it? Hopefully, maybe, you were thinking that we need to make that into a power. And that's what our third property says. If I want to do some number, n, times log base b of m, any number out front can become a power inside our logarithm. This is going to equal log base b of m raised to the n. If we're multiplying a logarithm by some number, that number will become a power inside our logarithm. So let's take a look at a couple of examples. The first one shouldn't be a big deal. 3 times log base 4 of x. Well, that number out front can become a power inside our logarithm. This is going to equal log base 4 of x to the third. That's it. Letter B, I'm going to do letter B in 2 steps. The first thing I'm going to go do is take all those numbers from out front, the 5, the 2, the 3, the 6, and I'm going to turn those into powers inside my logarithm. This is going to become log base 4 of y to the 5th. Minus. And let's just keep the minuses and pluses for right now. I'll deal with those in the next step. Minus log base 4 of, well, this 2 will become a power on that x, so I'm going to get x squared. And again, realize I'm just leaving that minus sign there for now. In the next term, that 3 from out front will become a power on the z, so I'm going to get log base 4 of z to the third. And to finish it off, I'm going to say minus log base 4 of q to the 6th. Now, I feel like this problem sort of looks like letter D from the top, where we have a bunch of logs that we're either adding or subtracting. I would like to see if you can take a moment right now and condense those 4 logs into a single log by deciding what from the stuff inside the logs will go on the top of a fraction and what will go on the bottom of a fraction. See if you can figure out what's going on the top and what's going on the bottom. I think the y to the 5th will go on the top, the x squared will go on the bottom, z to the 3rd will go on the top because we were adding that log, and the q to the 6th will go on the bottom because we were subtracting that log. One more of these, and then there's another idea that we need to look at with these properties. 1/2 times log base 3 of x. Well, that number from out front, that 1/2, that's going to become a power inside your log. You're going to get log base 3 of x raised to the 1/2, which is completely fine for the final answer. However, given where we're about to go with this stuff, I want to show you another way of writing this. You should remember that anything raised to the 1/2 is the same as talking about the square root of that thing. So x raised to the 1/2 is the same as saying square root of x. I'm going to say log base 3 of the square root of x. For right now, if the direction is condense, either one of these is fine. I just wanted you to see that second one because of where we're going to go with this stuff. So these 2 pages, we're talking about using these 3 properties that we saw to condense logarithms, to turn several logarithms into a single logarithm. What we now need to look at is going in the opposite direction, expanding logarithms. We have, like, the answer to one of those problems that we saw on the previous page, and I want to turn this into an addition or subtraction, or maybe a series of addition or subtraction problems that would give that particular logarithm. For example, in letter A, I see log base 2 of 3 times x. I see a multiplication problem inside that logarithm. Well, a multiplication problem inside of a logarithm comes from adding 2 logarithms together. I can expand this logarithm into log base 2 of 3 plus log base 2 of x. Take a look at this going in reverse and see if you can kind of rationalize that. If you add these 2 logarithms together, you're going to go and multiply the stuff inside. 3 times x is 3x. Yep, log base 2 of 3x. That's what I started with over there. See if you can deal with letter B and letter C. Letter B, I have a division problem. Well, a division problem inside of a log comes from subtracting 2 logarithms. So I can say this is log base 6 of y minus log base 6 of z. Letter C, if you have a power inside your logarithm, that power came from having some number multiplied by your logarithm out front. I can expand this into 6 times log base 7 of y. There's no need to write the dot over there. You could just say this is 6 log base 7 of y. Either of those is fine. So these 3 give us the basic ideas behind expanding our logarithms. There are no new properties. We're still using those same properties. We're just going in reverse now with them. In letter D, I want to look at the problem log base 9 of 3 times x squared. I'm going to deal with this problem in 2 steps. First, I see this multiplication problem inside my parentheses. I see 3 times x squared. A multiplication problem inside of a logarithm comes from adding 2 logarithms together. I see 3 times x squared. So I can write this as log base 9 of 3 plus log base 9 of x squared. Well, you're good with the first one. I guess we could do something with that, but we'll deal with that later. But the second one has a little bit more expanding you can do. That 2, that's a power inside your logarithm, can get moved out front by our third property. And I can say that this is log base 9 of 3 plus 2 times log base 9 of x. And I'll take that for the final answer. I suppose if you wanted to be fancy, we could go a little bit further. Log base 9 of 3, I actually know what that is. That's asking us 9 raised to what power gives us 3? Well, 9 raised to the 1/2 power, square root of 9, gives us 3. So I could say this is just the number 1/2 plus 2 log base 9 of x. I don't think you have to do that. I'm fine with you leaving your answer as log base 9 of 3 plus 2 times log base 9 of x. I didn't do this in the other number problems because in letter A, log base 2 of 3, well, it's not some good number. 2 to what power gives me 3? Well, some decimal that we'll deal with in the next section. So I'm just going to leave it like that. Letter E. Looks very similar to D, but it's different. Letter D said log base 9 of 3 times x squared. Letter E says log base 9 of 3x, that entire thing squared. The difference in letter E is both of those pieces are getting squared, as opposed to in letter D, where just the x was getting squared. I'm going to start from the outside and work my way in here. On the outside, I see a square that I need to deal with. That square that's inside your function, that can get moved up front. I'm going to say log base 9 of 3x. Because that square was applying to the entire 3x thing, as opposed to in letter D, where the square was just applying to the x. Now, I see a multiplication problem inside my logarithm. I can expand a multiplication problem into the sum of two logs. So I'm going to say 2 times log base 9 of 3 plus log base 9 of x. I had a multiplication problem. I'm writing it as a sum of two logs. However, this 2 up front, I need to show that this applies to this entire thing over here, even when it's expanded. So I need to just tack on some parentheses like that. My final answer here is 2 times log base 9 of 3 plus log base 9 of x. Letter F. We need to expand this, and I'm going to do this in 2 steps. I'm first going to write this as a series of addition or subtraction problems. I'm going to say this is log base 5 of, well, x squared was on top, so I want that to be a positive logarithm. Next, my y to the 6th is on the top. I need to add log base 5 of y to the 6th, which would have put y to the 6th on the top. The other 2 logarithms are in the denominator, and because they're in the denominator, I need to subtract both of them. I need to say minus log base 5 of z to the 7th minus log base 5 of q to the 8th. I realize that this is a multiplication problem, but it's a multiplication problem in the denominator. The fact that it's in the denominator means both of these are going to be subtraction problems. Now, you go finish this off and take all those exponents and move them up front before each log. And hopefully your final answer looks sort of like that. 2 times log base 5 of x plus 6 times log base 5 of y minus 7 times log base 5 of z minus 8 times log base 5 of q. And that is our final expanded answer. 2 more in here. Letter G. I want to go and expand this logarithm, log base 6 of x plus 1 squared. Well, this is kind of similar to letter E, where I have that square, that entire piece getting squared. I'm going to go deal with that square first. I'm going to move my 2 out front, and I'm going to say 2 times log base 6 of x plus 1. And now I have a sum inside my logarithm. I have a property that says if you multiply if you add 2 logarithms, you multiply the stuff inside. If you subtract 2 logarithms, you divide the stuff inside. But I don't have a property that talks about what to do to get an addition problem inside. There is no such property. This is as far as we're allowed to go. If you tried to separate this into like the sum of two logarithms, don't copy this down, just watch. We could say, I suppose, that's like 2 times log base 6 of x plus log base 6 of 1, which might seem reasonable. But if you tried to then condense it and try to get back to your original problem, well, when you add two logarithms, remember that means you multiply the stuff inside. So I'm going to get 2 times log base 6 of x times 1, or just x, which becomes log base 6 of x squared. That's not what you started with. There is no way that we can separate a sum or a difference that is inside of a logarithm. That's the best we can do, letter G. One more of these. Letter H, log base 7 of the square root of 3 times x minus 1. Well, first of all, I know that a square root is like a 1/2 power, so I'm going to go write this as log base 7 of 3 times x minus 1 in parentheses to the 1/2. Now this is kind of like letter E or letter G. I'm going to deal with that power, that's my outermost thing. I'm going to say this is 1/2 times log base 7 of 3 times x minus 1. Now I have an a multiplication problem inside my logarithm, 3 times x minus 1. I can expand a multiplication problem into an addition problem of 2 logs, and I'm going to say 1/2, and to show that it's going to apply to everything, I'm going to put some parentheses around this, times log base 7 of 3 plus log base 7 of x minus 1. The homework that I would like you to try, that you're then going to take pictures of and email to me, is page 50, 1 through 26. Before you try that, if you'd like to get a little bit more practice with these properties of logarithms, I'm going to add on to my website a worksheet with some expanding and some condensing problems for you to try, and I'll also put the solutions on there. So if you want to get a little bit more practice and check some of your work before you get into the homework, you're welcome to do that. As always, throughout all of this stuff, please feel free to email me if you have some questions on things. And I'm also going to be around Friday from 8 a.m. to 9 a.m. with Zoom office hours, and I'll send out more information about that Friday morning, about how you can log in there to ask some questions on these things. I just need to figure out how to turn this off now. And you just push the off button. Okay, goodbye. See you guys later.